Hey Sharks, it's Miss Luter again. Welcome back to Chapter 13, Lesson 2, Finding the Volume of the Cones. So this lesson, we're going to learn how to solve for the volume of the cone. Our I can statement is I can find the volume of a cone and the dimensions of the cone given the volume. So we're going to solve for the volume, and then we're going to work it backwards by solving for the dimensions when given the volume. Here we have our cone. When the cone is facing this way, it kind of looks like a party hat. And if you flip it upside down, it kind of looks like an ice cream cone. Either way, the cone has a base as a circle, and the point is the vertex. This is really important to know because if you look at these two shapes, both of these shapes have a radius. A radius is identified by the center of the circle all the way to the outside. And then the height. Pay attention. The height of a cone starts at the center and goes to the vertex. Later on, we're going to learn this outside edge is called the slant height. The slant height is different. In order to solve for the volume of the cone, you must have the height of the inside of the cone because volume is what takes up the inside of the shape. So remember, the height is always from the center of the cone to the point of the vertex. Now let's take a look at these two pictures. We have the cone versus the cylinder. Like I said, they both have the radius and they both have a height. But just looking at this, the cylinder is larger than the cone. And it has been said that if you fill a cone with sand and pour this sand into the cylinder, it takes 3 cones full of sand to fill the cylinder completely. So read that again. If I fill a cone with sand and pour it into the cylinder, I will have to take 3 times the amount to fill the cylinder, meaning the cylinder is 3 times the size of the cone, or in other words, the cone is 1/3 the size of the cylinder. So which of the following statements are true? This means the volume of the cone is 6 times the volume of the cylinder. I never mentioned 6. So let's keep going. This means the volume of the cone is 3 times the volume of the cylinder. Ooh, let's read it again. This means the volume of the cone's the smaller one, is 3 times the volume of the cylinder. That doesn't make sense. This is reading as in the cone is larger, 3 times larger than the cylinder. So let's keep going. This means the volume of the cone is 1/3 the volume of the cylinder. Read it again. This means the volume of the cone is 1/3, 1/3 being a fraction is smaller. So this is saying the cone is smaller than the cylinder. That's what I'm looking for. Good job. Okay, so you're gonna need this 1/3. Remember this 1/3 when we talk about the volume of a cone formula, which I'll go over right now. So the volume of the cone formula is 1/3 the volume of the cylinder. We know that the volume of a cylinder is read pi radius squared times the height, but now we're simply going to take pi radius squared times the height and divide it by 3. So if I were to write this in expanded form, it'll be written out to be pi times radius, because that's radius squared, times height divided by 3. Sometimes you'll see the equation written like this. Volume of a cone, right here, volume is 1/3 of the area of the base times the height. Or in other words, 1/3 pi radius squared times the height. But in my mind, it's easier to think about it as pi times radius times height divided by 3. So let's put it into action. We've got a small cone with the measurement of 8.5 as the height. Remember, it starts at the center and goes to the point. 8.5 centimeters is the height, and then it gives us 10.2 centimeters is the diameter. 10.2 centimeters as the diameter, but we don't need the diameter for our volume of a cone formula. We need the radius. Remember, the radius starts in the middle and goes to the outside edge, or in other words, it is half of the diameter. So let's make this statement true. We're going to find the volume of the cone, but we're going to leave our answer in terms of pi. Remember, if we are answering in terms of pi, that means pi, the symbol pi, will be in our answer. So we've identified that the diameter of the cone is 10.2 centimeters. And if I divide 10.2 by half, I know that the radius is 5.1 centimeters. So let's put it into our formula. 1/3 pi radius squared, but I know the radius is 5.1, times height, but I know the height is 8.5. And let's double check. Height is 8.5. Got it. And now let's multiply it out in terms of pi. Following our formula, we're going to leave pi out because that has to be in our answer. But what we need to do is do radius times height and divide it by 3. So let's try it. Radius is 5.1 squared, which means I do 5.1 again. So 5.1 times 5.1 times my height, 8.5, equals 221, but now I have to divide it by 3. Oh, I multiplied it by 3. Hold on. Go back. 5.1 squared times 8.5 equals that. Divided by 3 equals 73.695. 73.695 pi, because we are finding the formula of volume in terms of pi. Check. Much better. All right, diameter of the cone was 10.2. If we divide that in half, then we get 5.1 for the radius. Plug that into our formula, and we have 73.659 pi. And that would be the volume of the cone in terms of pi. But let's take it to the next step, and let's apply pi. So we know it is 7.3 times 695 times pi, and we're going to use 3.14 as pi. So calculator, please. Nope. Calculator, please. Thank you. 73.695 times 3.14 equals 231.4. 231.4. So we know the exact volume of the cone in terms of pi is 73.65 pi, but we can approximate using 3.14 to find the volume 231.4. Awesome. Let's keep going. All right, so now I got a party hat. Party hat with a height of 7, and it tells me the cone-shaped party hat shown here has a radius of 3 inches. We're going to find the volume of the cone, but we're going to use 22/7 in terms of pi. 22/7 is equal to pi because both of these are irrational numbers. So we have our formula, 1/3 pi radius squared times our height. It tells me that the radius is 3, and I know the height is 7. If I do my radius squared, 3 times 3, I get 9, and I'm still multiplying by my height, 7. So in order to do this, I like to show it to you on my Word document. If I were to have a party hat with a radius of a 3 and height of 7, I could work the volume formula like this. I would have volume is 1/3, there's my fraction 1/3, times my pi, but pi is written in the fraction 22/7, times my radius is 3, but we all know every whole number is a fraction over 1, times my height. My height is 7, but we all know that 7 could also be a fraction over 1. So pay attention. You have all these numerators in blue, which is multiplying. All these numbers are being multiplied. And then we have all of our denominators in green. And because every fraction is a division problem, that means I can simply divide by my denominators. So if I were to put it into my calculator, I would do 22 times 9 times 7. Notice I do not have to do times 1 because anything times 1 is itself. And I've already squared my radius. So I would do 22 times 9 times 7 divided by 3 divided by 7. Once again, I did not put in the ones because it stays the same. Let's try it. All right. I'm skipping the 1 in my numerator for the 1/3. Skipping the 1, and I'm just going to do 22 times 9, which my radius squared, 3 times 3 is 9, times 7, which is my height. And then I'm going to divide it by 3 because it's 1/3, and divide it by 7 because of pi. And I get 66. So my height would be, my volume would be 66. If that does not make sense, or if I went too fast, please pause and try it again. Because I have just less than 4 more minutes to go over the slant of the cone. Oh, 4 minutes. Let's see what I can do. Okay, the slant of the cone. Remember I talked about the slant of the cone is the outside edge. This is not the true height. This is the slant height. But because we're dealing with a cone that has a base and a height connected by a 90-degree angle, this could be a right triangle. If they give you the slant of the cone, you can use the Pythagorean theorem, a squared plus b squared equals c squared, to find the actual height. Here we go. All right, there's that right triangle from the cone. Base is 6, slant height is 14, and we're solving for h, which is the height, or in other words, the a. A squared is the height, b squared is the base, as in 6 millimeters, and we're solving for this, and then we're just going to plug in the hypotenuse, which is 14. That slant height is the hypotenuse 14. 6 squared is 36, 14 squared is 96. To solve for h, I'm going to subtract 36 from 96. 196 minus 36 is 160. And then I need to finally take the square root of 160, which is 12.65. So now that you were able to solve for the height, 12.65, you are going over the Pythagorean theorem to solve for that unknown height, and then we can plug the height into our volume formula. 1/3 pi times radius squared times our height, 12.65. Let's square out our radius. 6 times 6 is 36 times our 12.65. And then round to the nearest tenth. Oh my. So remember, to do it easy, we're going to do pi 3.14 times 36 times 12.65. And then finally divide it by 3. I have 476.652, but I want to round it to the nearest tenth. 476.7. Approximately 476.7. Got it. With 35 seconds to spare. So this is going to help you with your homework or your assignment. After you watch this video, please go to Into Math and you complete your on your own assignment. You're working on volume of the cone given the height. Please skip number 4. That one's talking about scientific notation. We don't do that just yet. You're finding the volume of the cone in terms of pi. And when given the slant height, here's 12, 13, 14, 15, slant height.